So today we're going to speak about hydrogen, something that is pretty old actually, and green hydrogen or low carbon hydrogen that is actually a pretty new trend in sustainability. So without further ado, I'm Fanny Shahi. I'm a director at Credit Agricole, CIP, and I'm the hydrogen coordinator for the Americas. And in no particular order, I will have everybody introduce themselves. So Eric, if you want to start.
Thank you, Fanny. Bonjour everyone, tout le monde. Hello everyone. My name is Éric Rondeau. I'm the director of the Green Innovation Center of Alstom in America. So nice to have everyone on board today to discuss about the potential of hydrogen in our economy.
Hello, my name is Gwenaëlle Avisuet. I'm working for Schneider Electric. I'm a member of the executive committee. I'm in charge of strategy, sustainability, quality, customer satisfaction, and merger and acquisition. Based in Boston.
Hi, everyone. My name is Wendy Franks. I'm the Chief Strategy Officer and the head of hydrogen for Northland Power. So Northland Power is a project developer, so I come more from the hydrogen project development perspective.
Perfect. So in the next, 40 minutes, we're going to shorten it a little bit to make sure you all get a break. But we're going to talk about hydrogen. Why hydrogen? Why are we talking about it? What is its role in the global economy? And so maybe what really triggered in the US, the even more biggest in the US and in Canada. I'm based in New York, so apologies, everybody. The Inflation Reduction Act came out in October 2022 with a huge subsidy for green hydrogen. It was the first time that really hydrogen was at the top of the headline. And what it says is North America is ready and is joining Europe in its fight for the decarbonization, because hydrogen has been around for 70 years. But we're talking about hydrogen right now because it's not the best way, but it's one of the potential ways to decarbonize some hard to abate industries. The Hydrogen Council, which Credit Agricole is part of, is forecasting hydrogen to represent 20% of the energy mix by 2050, 20% of the energy mix. And it's about $1 trillion of investment per year, just to give you an idea of how it represents. So why are we talking about hydrogen now? Why is it suddenly trendy? Well, first, all of you know really well that people are starting to be really, really committed to reach net zero by 2050. And most specifically, the financial players. We all starting to come out with our goals to reduce our scope 3 emissions, reduce our implication in oil extraction, reduce our overall our share of renewable. For example, Credit Agricole has some specific goals, but all of the financial players do have those goals to reach. And a lot of our institution are creating, which I'm part of, our low carbon transition teams. So that is the first step to really go in the direction and look at new technologies or old new technologies to decarbonize. A second very important point is the Ukrainian-Russian war, where the price of energy went up dramatically in Europe. So they are looking at alternative, and hydrogen, which wasn't economically viable before, is starting to be part of the equation. How to replace those fossil fuel energies. And so I'm gonna turn around to everybody. And to speak about like hydrogen in the context of our net zero target. And maybe we'll set the stage with the hydrogen landscape. So I'll turn to you, Gwenaëlle. Maybe explain to us, why is hydrogen? What are its potential applications? How does it come in play with the electrification? Is it competing? Is it complementary? So.
Yes, thank you very much. Very good question. So maybe to set the scene, talk about decarbonization. Everybody is talking about decarbonization. We can have meaningful discussion around the path, the speed, the rhythm, the technologies available. But the reality is that if we want to be in the 1.5 degree scenario, we have to go faster than what we are doing currently. So we need to halve the emissions, by 2030. How to do that? Relying on existing technologies first. We have plenty of existing technologies, including renewable energy, wind, solar, offshore, geothermal, etc., but also energy efficiency, reducing the demand, And we need also to invest in new technologies, emerging technologies that will take off. And this is where we end with this equation. By 2050, 20% of the energy will come from green hydrogen. This is where you have the play. But we need to go both in parallel, existing technologies that needs to ramp up and speed up and faster and scale, and in parallel, developing new technologies that will take off over time. So basically, up to 2050, we see a world where 70% of the energy will be electrical energy. And we need to green this energy. That's why we need to invest so massively into renewable energy. And in parallel, the remaining will be green hydrogen. In which cases? Is it useful in every cases? In reality, it's not the case. We need to have like specific applications for hydrogen where it makes the most of sense, and the rest will be more electrical. So what are the best use cases for hydrogen? I would say when it's used as a feedstock, So for example, for chemical industry, for the refinery, for steel, all this kind of hard to abate sector, this is the immediate use. And today it's already used, but it's gray hydrogen based on methane. So the key goal, the key challenge for all of us is to ensure this transition from gray hydrogen into green hydrogen. And these are two different technologies. On one side, it's working on methane. On the other side, for the green hydrogen, it's based on electrolysis of water, fueled by renewable energy. What's the biggest challenge? Cost, scale, and making sure that we create an ecosystem where everybody has a role to play in this direction. It's a new filière to build. This is something new. Why it's the right moment? There is appetite from customers, but still, what's the willingness to pay? Are you ready to pay 3, 4, 5 times more than gray hydrogen? And this is where we need the support from governments to bridge the gap. This is all about, this transition to happen. Huge investments on existing technologies, and at the same time, trying to scale, to orchestrate this new industry on hydrogen, because it has a role to play over the long term.
Absolutely, thank you. So basically, what you're saying is there's a lot of hydrogen that is used right now, but it's produced through steam methane reforming. So it's methane, it's gray, it emits a lot of carbon emission. There's a way to produce it with electrolyzer, renewable energy, very little greenhouse gas emission emitted. And so that's why we're talking about replacing the existing use. But there's also potentially other application. Maybe I'll turn to you, Wendy, and maybe looking at the outlook for green hydrogen. I know you do a lot of activity in Europe. That's where it all started. So if you can give us this perspective, and what are the lessons learned from there, and what's the outlook for green hydrogen globally?
Yeah, sure. So I want to say a couple of things just off the top. So the green hydrogen, you've explained it very well. So it's from renewable power through an electrolyzer to produce the molecule. What's really interesting about the hydrogen economy for Canada is that there's actually tremendous potential for economic activity in Canada centered around this industry. Why is that? The answer is that we have a tremendous renewable power resource, for example, on the east and the west coasts of our country, that has been up until now not harnessed. And it hasn't been harnessed because we don't have the populations. You just don't have the load. So people may have noticed yesterday that the federal government announced new regulatory framework for offshore wind in Canada. The framework for permitting offshore wind, it never existed before in Canada. So now we're starting to get that framework so that we can actually start building offshore wind projects. Why is this important? It's important because the wind resource for Nova Scotia alone is 15 gigawatts, which is the entire size of the offshore wind industry currently in Europe. The reason why it's not been developed is because there wasn't a market for it. If you take that green electron and you convert it into a molecule, which can be shipped over to Europe and sold into Europe to meet decarbonization and energy stabilization and security needs, now you have a market. And isn't that interesting? And that 15 gigawatt target or potential that we have on the east coast of Canada is the equivalent to at least $25 billion of investment and thousands of jobs. So I want to say that off the top, that this is a very, very interesting opportunity for Canada. The other thing that I wanted to say is that my experience, and I joined Northland Power 3 years ago, and one of my biggest surprises is the amount of time that I spend speaking with government and educating government about the opportunity. It's not just about the problem that we have to solve, it's also about the economic opportunity. It's not every day that Canada has the opportunity to grow a new industry that is export oriented. What is where the first green hydrogen projects are going to form is going to be in countries that have the most supportive policy, because as was mentioned,
Absolutely.
there's still a green premium. There's still a business case that we need to figure out. And the way that we're going to figure out this business case, like every other new industry that is formed, is there's going to be the appropriate policy and government support mechanisms. And the IRA was, it sort of was like it laid down the gauntlet for many other countries, and Canada followed almost immediately.
Yeah.
And we are one of few countries that actually followed almost immediately. And I think that's tremendous. And I really applaud the government for doing that. So I wanted to mention that. And then to your question, which I still haven't answered, which is the end use cases. I actually think you answered them very well. So I agree. So providing them in. So the hydrogen market today is 180 million tons. A lot of that goes into fertilizers, and a lot of that goes into precursors for chemical processes. Some of the biggest chemical processing companies, BASF, for example, they're based in Europe, and you have the most supportive policies that are coming in Europe. So you have supportive policies in Canada that, by the way, are happening at every level of the government, federal, provincial, municipal. And then you have the supportive policies in Europe, and we start by first replacing where the molecule is being used today, and then you can grow from there.
No, absolutely. I mean, it's very long and interesting. And so maybe to summarize a little bit, I think it's very interesting to see you as a renewable developer look at hydrogen. It doesn't seem, maybe people that are not in the space maybe are a little bit wondering why, but it goes together. The electricity demand from renewable power is going to just quadruple in the next 40 years. And so there is a problem with renewable electricity. You can't store it very long in batteries. It's not to say batteries are not important, but they have some limitation. And if you transform that renewable electricity in a molecule that can be stored very long term, that will help to kind of fill the gap between the application where you have the immediate electric use, where a battery is completely and perfectly capable of doing the job, and then where the battery has its limitation, then you convert to a molecule. So this is a very high level summary, but that's what we're talking about here. And so maybe talking to one of the main points we hear in hydrogen is where is the demand? We have the existing application. We need new application if we want to reach the 20%. So we're really happy to have Eric here. You're the demand person.
Yes.
And so, when you look at Alstom, why not have all your trains be electric? Why look at hydrogen?
That's exactly the right question.
Thank
First of all, Alstom, thank you for putting the slides, and I will explain a bit later. But first of all, for transport, maybe depending on the countries, 30 to 50% of emissions come from transport. Okay, in Quebec, I mean, it's a bit more because we are all electrified, let's say zero emission on our grid with hydropower. But it remains that overall, rail is about 5% of the emissions. It's quite efficient when you think of it in a certain extent. But it remains that this is where the slide comes in, if you can show up. In America, compared to Europe, China, and India, 1% of the rail network is electrified. 1%, nothing more. So the problematic of Alstom is, as we look to supply, let's say, a global market of railway industry. I mean, Europe, 50% electrified line by some other section that are not. We're providing alternative. And when we look at the huge market of America with 220,000 kilometers, just US, Canada 40, it won't be electrified. The ultimate solution would be to put catenary and electric wire everywhere. That would be the greenest train you can get, and then you greenify your grid. But it's impossible. So that's why we need to put solutions together. And beyond that slide, I will explain you the problematic, how we address it globally at Alstom. Next slide, please. We look at the problem is, as I said, to the extreme right of the graph, we could put electrification completely. However, we believe that we could put some hybrid solution between electrify some section, and combine with battery or hydrogen supply of the vehicle. So, and we see that also potentially also in the heavy vehicle for the application. And it comes to when do you electrify? When you have a high intensity of traffic and a high density of it. When you look at America, that's exactly the case to the left of the curve, low density and long distance and little frequency. So for short distance, we could put battery and electric or battery only trains. But when it comes to the long distance, this is where, how can we remove diesel of the path? California, CARB is coming with a regulation, coming with an agenda, aggressive agenda, 2030, 35, to remove diesel allocated to enter on locomotive in the state in the coming. It will cascade like the zero emission states on automotive in the coming months. So there's a demand there. We could be an off-taker, the industry of transport. With the case of long distance, the trucking is the same case as what we're showing for us. The example that we're setting the stage this summer, we're bringing our first hydrogen train operating since 2018 in Germany in operation here in Canada to show the ecosystem of green electron supplying an electrolyzer in Quebec and operating the train for the whole summer. And this is where we believe we can scale and bring the regulation and bring the justification of those green premium to close the gap. To close the gap to make it happen. In the same way that has happened in the wind industry, in the solar industry a few years ago, where you had electric tax credit to close the gap. And as we scale, price will get better, electrolyzer will be more efficient, there will be more capacity. But there's a huge potential we see there, but it's about the economic against the DSL. This is the beast to beat.
Absolutely. And so the problem is we can't wait for the price, and you said it very well during before we went on stage, like we can't wait for the price to go down. We have to act now, and we have to get project out now.
Yeah.
So because again, the goal here is to decarbonize our industry as fast as possible. So we don't have the luxury of time that much. So looking at, your own company and how they're looking at hydrogen, I'd be interested to see how hydrogen fits in the mix. Maybe just to talk about Crédit Agricole, and I know a lot of financial players are looking into it. There is one challenge: is the new old technology. It's not a new technology, but there's some concept of it that are pretty new, the electrolyzer, how you bring it at scale, etc. So it makes it hard to find, even on the equity side. I know venture capital and private equity are kind of looking at each other, being like, "Oh no, it's you. No, it's you. You should be looking at it." So it creates a little bit of where does that fit, and financial players are. We're not always very good at looking at something new pretty fast. So that's something we need to do. We need to educate, which is what we're trying to do here. That's what we're trying to do in our within our institution. And we're trying to look at all the value chain of hydrogen, hydrogen production, the electrolyzer manufacturing, the application, the storage, the distribution, etc. But it's very complicated and has its challenges. So we're trying to be a first mover. We were participating in the NEOM project, which is the first really at scale hydrogen production. It's an 8 billion project in Saudi Arabia. It had its specificity. It was not really a project financing. It was kind of a corporate offtake. So the financial players are going a little bit outside of their way to finance this project because we have our own very stringent net zero goals. So maybe I'll turn back to you, Gwen, and maybe if you want to start with Schneider's Electric decarbonization strategy, and how does hydrogen play a role, and the challenges you see within your institution?
So Schneider Electric is mainly focused on energy management and industrial automation, and a lot of the business is around software, how to accompany electrification, how to accompany automation through software. So you will tell me, how far is this from hydrogen? So basically, when we enter into discussion with clients, they want to decarbonize, and most of the time they don't have yet the full story. So what we do is that we accompany clients in the decarbonization journey. We help them to strategize, to identify ways of decarbonization. We have been developing also a kind of ERP for ESGs. They can measure, they can track, they can have all data regarding their footprint. And on their basis, our clients can decide what's the best way to decarbonize. Our role is to accompany this whole process. And when it comes to solutions, is to print numbers of different solutions on the table. Again, there is no one single solutions, depending on the end user. If it's a hard-to-abate sector, there may be different solutions from a building segment, for example. So what we do is that we offer a fully fledged set of solutions that can start from, energy efficiency, reducing the consumption of energy. That could be electrifying industrial processes from thermal generation into electricity. Or it can be, microgrids, because people would like to be more resilient and have on-site generation with solar, with batteries, and with all the software to optimize the consumption. And sometimes we have clients asking for hydrogen. Are we an electrolyzer company? No, we're not. But what we do is we deliver the whole software solution to accompany those projects. We were saying earlier there is a gap. Green hydrogen is much more costly from gray hydrogen. How to bridge the gap? Again, subsidies, we were talking about that. But it's also what the software can bring. When we offer, for example, digital twins for our clients, then it's a way to reduce capex up to 30%. Up to 30%. This is a huge enabler for emerging technologies like this one. So this is just one example, but also we were saying we need renewables. That's what we do also with the electrical equipments or with what we call PPA, power purchase agreement. And lastly, because we're talking about hydrogen, this is safety that we're talking about. And therefore, we produce, safety equipments for those kind of projects. So we accompany all these filières from the upstream to the downstream with the end user. And that's so important because at the end of the day, if we want to develop green project that would be affordable, competitive with gray hydrogen, we all need to have a role to play. From the end user up to the electrolyzer, up to the kind of technology component that we offer, that we deliver, because at the end of the day, we will enable CapEx reduction, but also OpEx reduction, because the operations will be much more well managed, because we will have predictive maintenance and things like that. So again, our strategy, I would really summarize it in 3 layers. First layer, everything should be electrified and with some electrical products, but then you have everything based on data reported on the cloud, and then you have edge control so you can monitor everything that is happening. Very important to visualize what's happening in a given project like that. And then what we have is machine learning, artificial intelligence, in order to predict predictive maintenance and things like that, safe operations. At the end of the day, again, our value proposition for the clients on hydrogen is reduction of CapEx, reduction of OpEx through software. And again, our strategy is multiplicity of solutions depending on the end goal of the customer.
Absolutely. I think it's very important to know there's not one size fits all. It also depends in where you are located. If you're in an area where you have a lot of renewable and energy, that's definitely it's interesting. Wendy, I'll turn to you.
Sure.
Same question.
Yeah.
Strategy.
So I'm going to pick up on the thread on electrification, because I love the point that you just made, because it's right our business, right? We generate electricity.
Yep.
So seeing this massive increase in generation is music to my ears. The question is just how to do it in an affordable way. But so I want to pick up a little bit on the grid. So the electrical grid, first of all, the market share of electricity in our overall energy consumption has been about flat for the last 20 years. And now we have this big hockey stick increase. So the role of the system operator in managing the grid and making sure that our electricity is affordable, reliable, and decarbonized is a tremendously interesting problem that needs to be solved. One of the things that's happening with the grid is as you bring more intermittent renewables into the grid, you are dealing with this up and down and these fluctuations. And when everyone comes home at night and they turn on and they want to consume a lot of electricity, you need to make sure that you can provide something. And that's called capacity in the system. A good way to provide capacity is through a natural gas peaker plant. And that's the way most system operators do it today. But of course, we want to get off carbon. There is an opportunity, and there's basically two ways that you could do that. You could do that with a battery, or you could do it with a peaker plant. The problem with a battery, most batteries, is it's only 4 hours of storage. So what happens if you need the electricity for longer than 4 hours? You need something else. And that's why we like natural gas plants, because you can run them for longer. What's the problem with building a new natural gas plant today? The problem is that you can only underwrite cash flows for about 10 years, because nobody wants to have a carbon generating asset 10 years from now, because we need to get off carbon quickly. So when you look at the economics, the battery starts looking actually cheaper because you can underwrite the cash flows for 20 years, 25 years. So what do you do about it? You figure out a way that you can put hydrogen into that peaker plant. And the hydrogen is very expensive, but the business case actually might work depending on what you believe on the cost of carbon, because you're actually only going to run that peaker plant maybe 12 times a year. And maybe you're going to run that for 10 hours instead of 4 hours. So it's better than your batteries. Everything has a role to play in the grid. So I wanted to share that with the audience because I think that's a really interesting application that people are working on today.
I'm so excited you mentioned the speaker plant, because I do think hydrogen will be one of the that's going to be one of the key application for hydrogen, because economically it makes sense. Eric, I'm going to turn it to you also. I mean, you kind of explained how hydrogen was part of your strategy, but maybe more globally.
Globally.
Yes.
Yeah. First of all, Alstom has given we're giving ourselves a target to be net zero 2050. That's the grandiose view. But 2030, we will not be producing any diesel vehicle. It will be some hybridized one that will still be, because we're not matching the capacity with hydrogen production. This demonstration train we're bringing in operation this summer works with over 1,000 kilometers of range. But to enter the scale of the power and the distance that we need to decarbonize the freight industry, we need to look at something more further out. So we will be looking on developing, let's say, a higher power system. But at the end of the day, as an off-taker, Alstom will be looking to partner with the ecosystem of the hydrogen, and we need to match the total cost of ownership of the diesel cost of operating. That's where, I mean, if we can reduce, let's say, the OPEX costs overall, and we can, let's say, be at match at the CapEx level when it comes to replace the fleet. I mean, this is where the supply of hydrogen needs to be at par, at least from the diesel point of view, with the incentive that we're all stating there. I mean, I hope that everyone will take the homework to read the book of Mr. Gates, How to Avoid Climate Catastrophe. There's a number of solutions and the concept of green premium in there. Everyone, please read this book in the next coming months if you have not. So this is the message where we need to work on the solution. Hydrogen needs to be at match to the fossil fuel with either the carbon tax that's scale up, or let's say the green premium that give us a chance to bring into capacity. But this is clear for us with the regulation coming in Europe, the regulation coming in the US, CARB again being, let's say, the forefront, let's say, pushing. The industry on the side, they're saying they will refuse. But look what happened with the automotive industry.
Yeah. I mean,
so that's where it's heading.
It's a good point you make, because we're talking about like hydrogen. There's nothing, there's no charging station, there's no fueling station, etc. I mean, we didn't wait for EV charging station all over North America to start deploying electric vehicles. So we can't expect the hydrogen economy to do that before actually starting to deploy some of the application on the mobility sector. So maybe just in the interest of time, I think we're going to go through one last question, but it's going to be very broad. There's one thing, maybe to bring it a bit closer to home here in Canada. This story is not from me. It's actually Katie Aylett from Air Liquide. Air Liquide has been doing a lot of low carbon hydrogen. She mentioned that back in the 13th century in Italy, in Venice, all the glass makers around the city got kicked out to a little city, which is Murano. And bringing them together, what it actually did is they started changing tips. They started looking at how they did things, and they actually all working close together had a lot of technology breakthrough. And yesterday I heard the word co-petition.
Competition.
Co-petition. And so I thought it was very interesting. I think everything sustainability and hydrogen in particular, we would need to work together if we want to have the hydrogen, low carbon hydrogen, which is again one of the key solution to unlock some decarbonization, some very hard to abate sectors. We need to work all together. And there's some challenges. Obviously, it's not perfect, obviously, but there's also a lot of opportunities. So just maybe closing on that, if you can speak about some specific project you've been working on hydrogen, the challenges, the opportunity, and also bring a little bit of what on the regulatory side could be done to just help a little bit more, I would really, that would be kind of the final closing question. So I'll start with Gwenaëlle, and then we'll do Wendy and Eric.
Just maybe to give you one example, a very recent one that we did in the United States, in Montgomery County. Well, it was a place where there was a bus depot, and the objective was to electrify buses. In reality, the first solution was to develop microgrid. So in that case, we developed solar plus batteries plus all the energy management software based on EcoStructure, our platform, digital platform, in order to optimize production and consumption real time. So, on-site generation for the electrification of the bus. In reality, more recently, they were asking for another brick to be added to that, which was green hydrogen. Why? Again, because of the complementarity. We know that batteries is much more for the short term. Hydrogen is giving the full picture of resiliency. And we see many, many cases for which the question of resiliency is on top of the radar because there, and reliability of the grid, for example. And in that case, a solution that is not 24/7 for, the available all time is not a solution anymore. So in that case, at the end of the day, we promoted these fully fledged solutions, including all those different technologies. Again, I think it's a good example because it shows that at the end of the day, that is something that we build with the customer. Step by step, by identifying what are the resources available on site, what's the request from the client, and at the end of the day, to fit with the requirement, we had to build all those technology stacks: solar, batteries, software, and hydrogen. All the combination. So this is one example, but on much more, I would say, scalable, much more traditional, I would say, hydrogen, as a project per se with solar electrolyzers and the end user as a hard-to-abate sector. We have developing project with Engie, with Technip FMC, so it's a big project called Hypester. And I would say, again, for this kind of project, first question, how to scale, how to make sure that we bridge the gap. All the questions that we were talking, it's the ground. It's what we see, in a given project. And that's why we are trying to find new business case. Who is the ability to pay for this additional green premium? Things like that. But you see, in that industry, it's not because we have those challenges that we should not go for it. So in that case, we create this kind of consortium where we share the risk, where we share the opportunities. And at the end of the day, it's all together that we can make the difference.
Yeah. It's like in the Bécancour area where everybody is kind of gathering to look at hydrogen and working on innovation. So I think it's important. The need for people working together is even more crucial if you want to bring the cost down to then make it to solve part of the equation, which is price.
Yeah. So here's sort of my closing remarks. I would say this is a tremendous opportunity for decarbonization, but as well for economic activity, which is great for Canada. I think that we need to get the first projects going. We need to get the money flowing into the first projects. And people need to be thinking about the risk in a different way, which means risk sharing.
Yes.
You're probably going to have first projects form where the customer of the product actually owns part of the project so that there's an alignment there, or the supply chain is actually owning part of the project as well. And we're doing that for a project in Colombia with Siemens. I wanted to highlight one other project that we're working on in Ontario, where it's all about figuring out the business case and understanding how the system works. And what we're contemplating is something where the electrolyzer will be directly connected to the system operator. And when you have a peak demand in the province, we're actually going to turn our electrolyzer off. And we get paid for that. And the system operator will pay us something for that. And that helps us to bridge the gap. So you have to bring these creative ideas to the situation to get these first projects going. Once we get the first projects going, we'll be able to establish that there's a clear market for it. And then I think we'll really be off to the races. But those first projects are going to require really creative, it's going to be collaboration, really creative thinking, and really, really good problem solving. Understanding the situation, understanding the system, understanding what all of the actors in the system need, and then providing that.
Absolutely. So you need to be creative. You need to go, the extra mile to get it done. So that's the kind of people I think we have in this room that have been working on sustainability for a long time. Your turn, Eric.
Yeah. Well, in fact, I'll give you the example of the project demonstration we're doing this summer. It's all about creating an ecosystem, demonstrating the ecosystem of the hydrogen from a small producer. It's effective. It's working now for a small fleet of cars. Now we're scaling it to the heavy vehicle with our train we're bringing. But at the heart of it, we're having the involvement of Transport Canada, Transport Quebec with us, to write the book to what's the difference from a regulatory point of view if we want to do it at scale, where we'll have to do it probably turnkey solution, partnership for the hydrogen supply on all the way to the operation. But we need to comfort the industry and let's say the financial industry, it's bankable and we can bring it in operation. So that's why, currently some people and some authorities was thinking that as we brought this train, we would, let's say, explode a crater in Charlevoix. It will not happen. This train has been operating for 2018. So the technology is maturing. We need to bring it, let's say, economically viable. This is where the game comes in for the supply chain as much as, let's say, the offtake demand of those technology. Yeah.
Sounds good. Well, I invite everybody, if you want a ticket to get on that train, to go and see Eric. I definitely want to give it a try.
You go on the web of Réseau Charlevoix, you can reserve your spot on the train right now, in fact.
Perfect. Yeah. That's perfect. I will open everything for question if you have some. Yes, we have. Go ahead, I don't know.
Hi, Réjean Gouyan from Adanda Capital. So thank you very much for this discussion. It was very inspiring. And I agree with you. We need this rainbow of solutions, I guess, to decarbonize the economy and decarbonize how we consume and produce energy. And talking about rainbow, you mentioned gray, green hydrogen. And so I was wondering, I would like to hear a thought about the pink hydrogen. Is it something that should be part of the solution also? Because I know that, building the green renewable energy requires some massive investment. It comes with some issues about lands, I guess. And also we need a lot of acres, I guess, to build wind power, solar panels and stuff like this. So what about nuclear energy to produce hydrogen?
Does someone
I can take that. Okay, so every report that I've looked at for new nuclear power is one of the most expensive forms of electricity. Yeah. And electricity forms 60-70% of your total cost of hydrogen. Yeah. So if you're talking about generating hydrogen from electricity based on new nuclear, I'm not sure how that makes sense, unless you dramatically bring down the cost of nuclear. And the problem with nuclear is that it's really, really hard to build. And so there were 2 nuclear plants that were being built in the US. One of them took the whole company bankrupt, blew through $2 billion of equity, took out the whole Public Utility Commission. The second one is Vogtle, which is just reaching commissioning right now. And I'm talking nuclear at scale. So I'm not sure how that works. I think the SMR technology, which is small modular reactors, that's going to come. It's this is a toolkit of solutions. We need everything. To your point, it's a lot of land that you're going to need. So do I think SMRs are going to come into the grid? Yes, it's just going to take a lot of time, right? So the first SMRs are expected to get commissioned in 2030 2030 if we're lucky, maybe 2035 in Saskatchewan. So I think that's going to take some time. If you're talking about the existing nuclear fleet, where you could run it at a little bit higher efficiency, I think there's something there because those assets tend to be fully depreciated. So the cost of electricity from a fully depreciated nuclear plant is actually quite low. Now, the only thing with that, as far as I know, is the biggest nuclear fleet in the US is actually running at like 90% capacity. So I don't know if that exists anywhere. But if you can find that somewhere, I think that's a good thesis.
So this is very frustrating because I think we could keep speaking all day about the topic. We've only touched, I would say, maybe 2% of what's happening in hydrogen. But it's been a very, very interesting conversation. Just to go back on nuclear, maybe to close on that, on top of everything, I think nuclear has some specificities that are different from renewable. You have the waste management, etc. I think even though it is part of some of the framework, you still see some investors when you try to include it in your green framework that do not really want to have it included. So I think on the financial side, just to answer, there's still some people that just will not do nuclear. But if you look at the Inflation Reduction Act or the Canadian roadmap for hydrogen, I think we need everything to decarbonize, and so they're very technology agnostic as long as we're speaking about low carbon hydrogen. So maybe that's it's an like more theoretical answer, and then in its application, we are seeing some small green hydrogen project, low carbon hydrogen project with nuclear, but it's very case specific, location specific. So maybe thank you everybody for this panel. Please don't hesitate to come and ask questions at the end, and thank you for having us today.